So here we are in Otago Harbour, and this is Zoe, and we're at the Portobello Marine Lab, which is towering up here above us. And Zoe's going to tell us a little bit about one of the most commonly experienced movements of ocean water, and that is the tide.
Hey everyone! So yeah, right now we're at low tide, so that's the trough of the tide cycle. And the tide cycle happens every 12 to 13 hours. Low tide was about 9:55 this morning, and then it's going to slowly start creeping back up. And tides are affected by the moon, so you'll have different levels of low to high tides, and also the Coriolis effect of the Earth, so the spinning of the Earth.
So that spinning like a roundabout sort of tends to throw things around in a circle.
Yeah, and so that's causing that trough to move, so you have this wave almost moving around New Zealand.
Okay, yeah, right. The gravitational wave that's been sucked up. Yeah,
to create that. And if we pan over, that's Jess over there, another PhD student at the university, and she's at the marking of where the high tide comes at the North Shores here of PML. And so that fluctuation is where you have the low tide, and the wave can come all the way up to where Jess is, and then back down.
Okay.
So here's a graphical schematic, I don't know if it's drawing, of the tide cycle. And what you can see is right now we're at low tide, so this is the trough of the tide. And then in like about 6 hours, you'll hit high tide. And so it fluctuates every 12 to 13 hours.
So that height for here in Otago Harbour is about 2 metres, like we saw with Jess on the cliff.
Yeah.
And so we can expect that where you're standing now, you'd be up to your neck at least in water later on in the day.
Maybe not up to my neck, but yeah, it does get pretty high.
Okay, so this water, if we look out here, is coming in through the harbour mouth around the corner there and bringing water in from coastal Otago and mixing it into the harbour here. Okay,
sure.
Very good, thank you.
So we've had a wee think about water masses in terms of density and their salinity and their temperature, but another thing that will drive water movement in the ocean are winds and currents. So the atmospheric temperature and the rotation of the Earth, they drive surface, that causes winds, and these winds drive surface currents along around in the big ocean basins. So the prevailing current that comes in the west of New Zealand comes from the Tasman Sea, and it travels in a northwesterly direction down along the west coast. And then, so this warm subtropical water travels down the west coast of the North Island and then the South Island, and then it will make its way through Otago Strait and around the bottom. And that's where,
so then you have kind of from the roaring 40s this colder water that is not quite coming off Antarctica, but this roars past kind of the east coast of New Zealand. And as you can kind of see here, with this blue, you got these two currents. So as you can see here, we have the cold blue, and this is going along the east coast, and what it's creating is like two currents kind of circulating around. But this is colder water. And this purple, is even colder, kind of like Antarctic water that is sinking because of being cold water, and kind of goes underneath.
And that the colder water is the deeper purple water, and it's underneath. And that's part of the big ribbon that connects the world. That's all the Atlantic water. And this is the southland current of the cold water coming in here. And is our model fair? Are there eddies like this in behind Banks Peninsula, and does the water move back and forth through Cook Strait like the way our model shows?
yes.
Yeah, okay.
Does.
And it looks like there's currents that go off the Cape here as well. So our model's a pretty fair simulation.
peninsula here. Dunedin City in here. This is where we are here at the Marine Studies Centre, right next to Quarantine Island in the middle of the harbour. Now, if we think about what the tides are doing and where the inputs are in the system, we've got the Leaf River, which is bringing in a whole lot of fresh water into the inner harbour right here. And then outside of, down south of the peninsula, we have that southern current, which is bringing that subtropical water up the east coast of the South Island. And as it comes past the Otago Peninsula, we get kind of an eddy forming. That's going to be retaining that water inside the harbour.
And then the tide comes into the harbour, that red salty water comes in
Yep.
and meets the fresh water.
Yep, so especially in this outer part of the harbour, we get a whole lot more mixing and turnover from that coastal environment. And
There's a little bit of fresh water sneaks out of the harbour.
yep, a bit of fresh
Okay.
water coming out of the harbour. And then we have some other freshwater inputs a bit further south from the Clutha River. Really big freshwater input from there. Lots of sediment coming out of there too.
Right, and that sediment ends up getting moved north by the southern current as well.
Yeah, so it'll come up along, get entrained in this wee eddy here that forms
Yeah.
behind this headland.
Yeah.
I don't have enough.
Okay, yep.
Oh,
And
yeah, here we go.
here's that eddy. And
Yeah, so here we get this eddy
there.
forming, the sediment's
Yeah.
getting entrained into up here where Blueskin Bay is.
And we're here now seeing that eddy, and we're looking down the entrance to Otago Harbour.
And then here we have the Aramoana
The tide's
Mole.
going out at this point, tide's coming out, so a bit of fresh water's coming out. And then, so the tide, and then again when the tide comes in, the salty water comes in.
So we're just going to do a wee simulation of the Otago Harbour. So we've got our freshwater influence from the Leaf River in the blue. So lots of rainfall collecting in the hills, coming out of the Leaf into the harbour. And then the tide, so the salty coastal water, when the tide comes in into that harbour, you'll see that salt water is more dense. So it's going to flow along the bottom of the harbour underneath that fresh water coming out from the Leaf. And of course we've got different parts of the harbour. So the outer harbour, there's going to be more salt water coming in as opposed to the inner harbour, which is a bit more protected.
A little dark here, but we'll show on the board what this is showing from low tide and when that kind of salt wedge and drawing up to high tide. And so if I come over to the board, if we have kind of our, and this is our shore, I should have done it that. And this is kind of that fresher water. You'd have, while going into high tide, saltier water kind of driving a wedge into the water, which makes this water on the shore rise up. And we'll go down to the north shore of PML to show you where the tide is now from when the low tide at the beginning of this video. Cool, so we're now back at the north shore of the PML lab, and as you can see, we're at high tide, so the beach we were at no longer seems to exist. And if you look over my shoulder, the outcrop of where Jess was earlier is completely underwater. And so that is where that peak of that trough of that map of that parabola. So before we were at the bottom, that trough where low tide is, and it's moved all the way to high tide. And it might keep going. I don't think we're quite at high tide, so it'll keep rising up. So I won't stay here too long. Why this tide is so high right now is because we're at a spring tide. So the sun and moon are working together. We're going to have a really high tide and a low tide. If it was a neap tide, if you've ever heard that term, that's when